All right, I had some more thoughts on my previous video about the movement of the sun, and I didn't really have a lot to add. I pondered about it all day, but I finally found some illustrations that I think will help add fuel to the fire of questioning how this all works. I found this set of things, and I replaced this one in the middle on the equator just because it had degrees marked. And you can see there that within the tropics, the sun's path never tilts. See, these on the other, hemisphere, different seasons tilt, but between the tropics, it does not tilt. Even if it's, it doesn't have to be an equinox. According to this diagram, which came from a physics site, the sun would rise and set at 6 a.m. and 6 p.m. On all the models, although that one, or all the past, yeah, I think that's a 6. It looked like a 4 for a second, but I think these all say 6 a.m., 6 p.m. for rising and setting, and solar noon is just different heights is all that really changes. But you gotta wonder, I mean, the sun is moving, but through the seasons, it'll go summer solstice, equinox, winter solstice, and back again. But these never tilt. But what's really interesting me, really puzzling me right now is this one, because we're looking from the south to the north. And we know this because the tilt is the opposite way. If you remember yesterday, I was looking more at this kind of an arrangement where, and this is what I observed, where I'm here in the northern hemisphere looking south, and this is from the opposite angle. I was looking from this way in my illustrations. Now we're looking this way. And the sun starts out north of east, goes south of east at its zenith, and then comes back again north on its way to setting. But in the southern hemisphere, on the current standard model, they have it tilting the opposite way. See, from the northern hemisphere, things tilt south toward the equator. Southern hemisphere, the things being the path of the sun tilts north toward the equator. So this end and this end are tilting toward each other. These are straight up. The ends toward each other does not work with this, because even if you just look at this side, okay, June solstice, and I'm told that because the reason the sun takes this path is because, see, the Earth is spinning this way, right? And so from our perspective, if we're just sitting still, the sun is moving down like this, okay? It's moving in the opposite way. So think of, there's another line. This is a circle going all around this globe. And so there's a line coming down that the sun is going to take. It's going to reach its zenith and go back this way. So, and this is what I observed, that the sun is north of east. Okay, it's going to look above me. And then it's going to go south a little bit of my, this is the Tropic of Cancer. I'm just using this line for convenience, but I'm actually up here. And it'll go south. It does not go exactly 90 degrees. It never gets more than this, about this angle here. So the sun starts out north, goes south, and goes back north, okay? But these lines are also parallel, so they're doing the same thing. The sun should come down, hit here, go back up. But what do we see here? If you're in the southern hemisphere looking north, the sun is starting toward you in the south and moving away. And that puzzles me, because I went back and forth on this all day long, and I'm still not sure if I've got it right. But the thing is that both northern and southern hemispheres are tilted at the same angle, obviously. So the sun should have the same angle of tilt. But according to these things, they don't. This is straight in the middle at the equator. On the north side looking south, these paths of the sun, like this is the June equinox, pointing toward the equator. In the southern hemisphere, the June equinox is way up here, but it's still pointing toward the equator. How can both of those sun paths point toward the equator when they're all at the same angle? And this one is the sun goes down and then up, meaning it starts north, it goes south, it goes north again. Should be exactly the same in the southern hemisphere, according to these lines, that the sun should take this path around, because from our perspective, we know it is, according to the standard model, it's the opposite. The Earth is spinning, but from our perspective, and I verified this with physics sites, that where other people ask the question, what does it look like from our perspective? And they actually showed this kind of a disk flat Earth with the sun going over it at these angles. But what they all say is the sun will, like, for example, like I said, here's east to west line, and I showed this from a different angle yesterday, or I think it was yesterday, whatever day it was. The sun starts north of east. I verified this by my own observation at the June solstice. It went south of 90 degrees. That is to say, it went about 70 degrees, so it was tilted. It was not directly over my head at its zenith. And then it went back north of west, okay? So north, south, north should be exactly the same for every one of these, north, south, north, but it doesn't in either of these. In the southern hemisphere, looking north, it goes south, north, south, and at the equator, it just goes straight up and down. How can this be? These are observations, okay? Now, I was wondering, whatever day it was I did the other video, I was wondering whether the south did the opposite of the north, and according to these diagrams, they do. In other words, at the June solstice, the sun goes north, south, north, and here, looking from the south, looking up toward the equator, it goes south, north, south. So they're mirror images of each other. We've got lines going, if you envision all these on the same half dome, they angle up toward vertical and then back down. But that can't be true here, because even, like I said, if you freeze time at the summer solstice, which is what the June solstice is over here, and I'm told that this north-south-north path that I see here is, we can just basically follow this line. Well, all the lines are parallel, then the sun must go north-south-north, even in the southern hemisphere and the equator. But according to this, at the June solstice, which I think on theirs is, well, this is north, so that'd be this line, is still straight up and down, 6 a.m., 6 p.m., 90 degrees. It's just a smaller arc. But in the southern hemisphere, at the June solstice, it's leaning toward the equator. Okay? So how can that be when all the lines at that moment in time on the June solstice are going the same angle, and we don't have north, south, north anywhere except the northern hemisphere? That's the puzzle I'd like to have solved. Because whatever is true of this line is also true of this line. The path of the sun is the same. It has to be the same. No matter what model you have, as long as there's one sun, it can't go in different directions at the same time. So given this makes sense, then it makes sense that in the equator, and the southern, or the Tropic of Capricorn in the southern hemisphere, the sun also takes the same path, north, south to its apex or zenith, and north, south, north. But it does not do that at the equator and the southern hemisphere. Equator goes straight up and down. Southern hemisphere goes south, north, this line, south, north, south. The tilt is the wrong way. They should all tilt. Now, I understand, like I said, if I say this is an arrow like these other ones, and this is a markers, okay? I put a marker here, here, and here, all in the straight line like this, And I have them, well, one's going to be a little farther out here, and I have them like that, and I turn that ball along that polar axis and spin it. It's 23.5 degrees, and I spin it like that. If I have these 3 markers here, they're going to make these lines at those angles. Okay, so supposedly that's the path of the sun, which means they're all should have the same sun path, and look at that, they don't. Now we know that they vary from one solstice to the other. I don't have a problem with that, and they're consistent on each of their own sections. But when all 3 sections have one sun making the same motion, it's impossible to have the sun going 3 different directions at the same time. So I'm just saying these top 2 rows are observation. The bottom row, that standard illustration of why we have seasons, doesn't work. And I'd like somebody kindly to tell me how it works, because if it can't work, then I don't see how the globe model can work. And then the question is, what does work? What does account for different angles of the same sun? June solstice is going at this angle in one hemisphere, this angle in another, and straight up and down at the middle. Name me a model that takes care of all those problems without resorting to something that doesn't work, like this bottom model. That's the question. And I got a lot of noise here and hardly anybody watching, so I'm just going to leave this up. It's going to be real short. It's only been 12 minutes, so that's the question. I know it's Saturday night and everything. Everybody's busy, and everybody don't forget to gear up for the eclipse coming. I think it's a week from Monday. So anyway, somebody answer this question for me. See you again sometime. And let me stop sharing that screen, and then I can find my stop button. Thanks for coming.